Okay, within Alice, there is one final method of repetitive code, and that is a method known as recursion. Recursion is when a method calls upon itself, and in some cases, it can be a little bit more practical than using a loop. Repetition. Repetition is basically just taking code, and I got an update coming in, so we'll just postpone that. Repetition is just nothing more than taking code and asking it to execute more than once. Now, in some situations, we don't know exactly how many times a block of instructions should be repeated. That's a perfect opportunity for, say, a conditional loop or possibly even recursion. All we know is that the repetition is needed. So, for example, in a board game like chess or checkers, we don't know exactly how many moves it will take for a player to win or lose the game. All we know is that several moves are going to be needed. Okay, so in that case, how do we write program for that? Program code. Indefinite repetition. This is in programs where a count of repetitions is not known. It's indefinite. We know it needs to repeat. We can use one of two repetition control mechanisms. We can use recursion, or we can use a while statement. So a while statement basically means do while this condition is true. Okay, so this session is going to focus on recursion. We'll talk about the while statements in section 2. All right, so recursion. Many of the pieces we use to create a program are identified by using special words. Control structures, do in order, do together, if else, and even loops. Recursion is not a program statement with a special word that identifies it as part of a programming language. And what recursion is a method calling upon itself. Now, one of the examples, this is one that we are going to do in class together, is the horse race. Let's say that we are building this carnival game. In repeated moves, one horse is randomly selected to move forward. The selected horse then runs straight ahead to the finish line. A horse is the winner if it gets to the finish line before any other horse. When one horse wins, then the game ends, no matter where the other horses are in the game. In order to do this, what's our story board going to be? Race, which means if one horse has won, the winner is going to say, I won. Else, randomly choose one horse and move it forward a small amount. And then we want it to do everything again. So we want to call upon our race method again within itself at this point in the storyboard. So do everything again means that the entire method should be repeated. To do everything again, the method has to call upon itself. So in order to do this, let's take a look at breaking this down in stepwise refinement. All right, so race, if one horse has won, then we can call that method is game over. The winner says I won. That means that's going to be which horse won. And then finally, in the else, move random horse forward would be our three methods that we are going to use that are going to be stepwise refined into the race method. So let's take a look at the demo and see how this one is going to execute. I'll bring that file up here. Just give me a quick second to do so. And then we'll take a look at how this code is going to execute. All right, so here it is. Let me just bring up so you can see what recursion is. Here's the method. So the method is race, racehorse game.race. Notice how it calls upon itself in the method itself. So that's what we call recursion, when a method calls upon itself. Let's go ahead and execute the code and see what happens. Notice how the horses are moving forward at a random rate. Horse 1, horse 2, and horse 3. If we speed it up, the finish line randomly. There we go. Horse 1 wins that one. Let's speed it up and restart it. Horse 1 wins again. Now, if you do this enough, we should have different horses that are going to be winning the race. However, we see what's happening here is we have a definite tendency of having horse 1 tackle that here in just a second, but that's something to keep in the back of your head. All right, so the concept illustrated in this example. First of all, in games, a conditional expression is often used to determine when the game is over. This is a condition that needs to be put in place. When is the game going to end or the game continues? In this example, the game is over when one of the horses gets within half a meter of the finish line. That means that horse won. The same condition then is used to determine the winner. Random numbers is used to introduce an element of chance into the game program. So the user has absolutely no control of which horse is going to win the race. Random numbers that are generated in a random number function is what's determining the winner of the race. So to test the program, here's what we find out. If we went ahead and ran it if we ran the program 20 times, testing a program that uses random numbers requires a couple extra precautionary measures. First of all, in this example, we ran the program, let's say, for 20 times, and we found that racehorse 1 won 7 times, racehorse 2 won 3 times, and racehorse 3 won 10 times. Something is wrong because each horse should win approximately 1/3 of the time, and that's not happening. So if we take a look at the next example, which is going to be version 2, the bug in the first version of the program is that it has nested if statements and a 33% probability of for each if statement. What we didn't consider is that racehorse 1 was not selected when we have a 50% probability of selecting either racehorse 2 or racehorse 3. Okay, so keep that in mind. Let's take a look at the second example. If I bring up the method here. I'll show you this one. I wanted to show you this method because choose true 33% of the time, and then 33% of the time down here also. However, there's 3 horses, so once one of the horses is eliminated, the other 2 horses, it's a 50-50 chance that one of the other 2 horses is going to be selected. So we have to adjust that probability. That's what we're going to do in the second version. Let me bring that up so that you can see that. All right, so here's version 2. Let me show you those methods again. So now, after one of the horses has been eliminated, there's a 50% chance that one of the other 2 is going to be selected. So we have to change our probability numbers here. Now let's go ahead and play the world. Speed it up. Okay, there we go. Horse 2 wins that one. Let's run it again. Watching the horses. Horse 2 wins. Horse 3 wins. Horse 3 wins again. So now we have 2 wins for horse 3, 2 wins for horse 2. Another win for horse 3. But what we're finding out here is that it's definitely a lot more. Now, horse 1 hasn't won a race yet, but it's not dominated. If you remember the first version, horse 1 won the first 4 races by himself. All right, so let's go back and take a look at how this impacts our code and the probability of our code operating properly. All right. So if we ran it a number of times, you can go ahead and test this on your own. Go ahead and test it. Run it 30 times and see what happens. See what you get for numbers. That'd be interesting to see what they come out to be. All right, if you haven't already done so, please read Chapter 8, specifically Section 1 on recursion. You should have already done that, though, before you watch this presentation lecture. After we have completed our in-class example, which we'll do together in our next class period, Chapter 8, Lecture 1 lab will be assigned as we have in all the other chapters. This concludes the Section 1 for Chapter 8 presentation lecture. If you need to, please feel free to review any of the slides that we've gone over today.